Hi everyone. Okay, I need to work out where I stand so it doesn't echo. This is good. So, my name's Caoilte O'Connor. So Christian almost got it right, but that's great. I'm a developer from London. I work at a company called ITV, which is short for, I think, I'm not even sure, International Television. And it's a broadcaster, essentially. It's been around for over 50 years, I think, and started out just being one television channel. They made Britain's most popular soap opera, and over the years, of course, as satellite television came and digital television came and the internet came, they've grown and done more stuff in the digital space. There are now applications like phones and smart television, of course, on laptops, and watch the television programs that we make up to a month after they're broadcast. So I work in the team that helps to support all of that. And I've been there for about 2 years. And when I started at ITV, they came to me on the first day and they said, well, actually before that, during the interview process, and they said, we're going to be building microservices. And I said, microservices? Oh, yes, of course, no problem. 2 years ago, I don't think you could search on Google and find more than 2 talks, maybe 1 article on the subject. It's been amazing over the last 2 years how this scene has exploded, actually almost literally in the last year. We've had 2 conferences now, loads of talks and presentations online, and loads of articles. It's the new hotness, and that's been really exciting for me because those 2 years ago when we started out, we tried to figure out for ourselves what these microservice things were. And we thought we knew, but we couldn't be sure. And now we've been seeing lots and lots of presentations and these articles, and we've been discovering that other people think more or less along the same lines. That's been fantastic. But there's been a few things where we've done things that we haven't seen people talk about. They may well have been doing them, but it's a broad subject. And I felt there'd be an opportunity to talk about that space and fill that gap. And so that's how this talk came about, and how I went to Berlin, and then how Christian and his colleagues would have heard of this and invited me here tonight. So it's really exciting to get a chance to give it again here. And I should actually say that it may have been the best talk of the conference so far, but it was also the first talk of the conference. So, I said I was at ITV for 2 years, and the talk today will be about one of the projects that we worked on at ITV. And I'd say we were working on it for about a year, but it represents about half a year of development. And so the talk today will be shaped by that project. And so you could say, and I like to, that like any good TV show, like we produce, this talk is a story. It's how we went from starting out, and how we got to a good place, and how things went wrong along the way, and how we triumphed in the end. Also, like any good TV show, especially the ones that we make, there's a few places where I massage the truth a little bit to fit things into an hour slot. I even outright lied quite a lot. And so bear that in mind. And if afterwards it seems like things went awfully simply for us and things were really easy, that's not true. And I've papered over the yawning chasms of the problems that we actually had. Now, I'm going to be splitting the talk into roughly 4 parts. So we'll start by, for me, just trying to talk to you about the challenges I have doing talks on microservices, or seeing talks on microservices, how my feelings on microservices shaped this talk tonight. We'll then talk a little bit about how the constraints of the project we were working on at ITV shaped the architecture that we produced, because I think it's really important to understand the context that we were working in. Then we'll start from the beginning with building up the microservices that we developed and how we naively went about aggregating them together. And then how that developed, how they went wrong, and how we got to a good place in the end. At the end of the talk, I've got a little section on versioning, because it came out quite nicely from a lot of the other work that we were doing, a great way of versioning our microservices, because we were putting so many of them together, we had to think about things a little more than I have done on other projects. So, how do you build microservices? Well, according to James Lewis, who is somewhat of an authority on the subject, you do it by standing on the shoulders of giants. And I think that's a great quote, and I'm always thinking about that when I'm thinking about microservices. Although it's also a little intimidating, because what James is saying in a very consultancy fashion, because he's a very consultancy person, what he's doing is putting a positive spin on the fact that in actuality, microservices are a bit of an iceberg. Here's the authoritative book on the subject, Building Microservices by Sam Newman. It's a great book. You should all read it. And the thing is, lurking beneath the surface are all these other books that you kind of also need to know about. Listening to a talk that I or anyone else is giving on microservices, or if I'm giving a talk on microservices, I kind of need to somehow share these things with you. Or if it'd be really nice if we were working on a project together on microservices. We need to have this shared understanding. Now these are books that my team pulled out the hat and said they thought would be great books for everyone to have read, and we just don't have time in any talk to go through the things that, even in a very superficial level, these books would cover. But even if we think about these books as a firm foundations for microservices architecture, that presents problems as well. I mean, if I do a talk, I would say I could probably cover the foundations. But I really want to get into some depth today. So I'm aiming to go very narrow and very deep. I'm going to be talking about composing microservices together, but I'm going to be looking at it from a development and an architectural point of view. So a lot of domain modeling and enterprise integration patterns, not so much things like testing, operations, and the most important thing of all when you're doing microservices, which is culture and how you organize your teams. And those are really important subjects that a lot of these books cover, and they need their own talk in their own right. So this is a screenshot of the application that we built. It's a smart television application. So you would use this with a remote control. And it's for Samsung televisions, I think, but we're launching this now on lots of other TVs. And it allows you to watch ITV shows from the last 30 days, as I was saying earlier. And the thing that's actually interesting for us, as we started this project, was that they already had an application. It wasn't nearly as beautiful, but it provided all of the same content. And they were asking us to write this new application, but also to write the APIs, the new APIs to support it. And it was really important for us to understand why, not just blindly run ahead and do it. And so we started out by finding the manager, I should say managers actually, who maintain those existing IT systems that we'd be replacing, these APIs that are needed to support an application that you can watch video on. And we said, why do we need to replace those systems? Why do you want us to do microservices? What's going on? And what they told us was, our current systems are very difficult to understand, not just for us, the managers, but also for the developers. It takes us a long time to change them, and we've frankly reached the end of the tether. We can't go on, we need to replace them. And I think a lot of us are familiar with that situation, so that was something we could grasp. But there were also other IT systems. ITV is a large company. We weren't just we couldn't just concentrate on the department that we were in, because all of our content had to come from videos were made, and there were teams that were working in other parts of the company. We needed to talk to their IT systems. We talked to their managers, and they told us that The core systems at ITV, they are also really difficult to understand, even harder to change, and worst of all, don't scale. That's a real problem, and it's possibly one of the reasons that the IT systems we've already got are in such a mess, because they've been trying to deal with these legacy systems, and it's caused problems for them. However, we're not yet ready to replace them. So as you go out there and you build this replacement, you're going to have to build on top of these really shaky legacy systems. Now, we had an architect on the team, and he was working with us and with these managers to try and figure out and help us to decide on a strategy and a vision for the project. Because he's my favourite type of architect. He's a very rare architect, an evolutionary architect, I've seen them called. He's less concerned with telling the developers exactly how to write their code and exactly how their APIs should work, and much more interested in getting all the data together, all the background information the team needs, establishing the goals and the vision that they should be working towards. And he looked at this problem and what we were seeing, and it was him that decided on microservices, because what he thought was, we need to isolate and protect those core systems, and microservices will help us do that. We want to stop those, the replacement for our existing APIs to serve our video applications from becoming this unmaintainable mess again, and microservices will help there. And also we want to provide a good example for the rest of the business that they can follow and that they can integrate with, because you know, we want to be the change that the business wants to do but doesn't know how. And so architecturally, we wanted us to keep things very simple and to use REST as an integration pattern for our microservices. There's lots of other ways of doing microservices, but REST is the lowest common denominator that everyone these days has got a good grasp on. So that's where we were starting from. And we set out to build what I like to call domain services, and really this is just to say that these are the most fundamental basic building blocks in an architecture, in a microservices system. The smallest pieces at the base level that just describe working and let you work in one domain alone. But the problem was, when we started out, we weren't actually sure what domains we were working with. We knew we were building a video application, but we needed to sort of start by identifying some basic microservices that we could build. And so we were looking for these domain services to begin with, and we did that by taking a screenshot from the application that we'd be building. This is a player from the same episode page. And we knew we needed to build this, and we were sure there were lots of other domains at ITV, but we were interested in finding the ones that would be needed to support this particular page to start off with. And so we started modeling where the data on this page came from. And I think that's not actually that unusual. I think lots of people developing traditional monoliths do the same thing. But we were looking for groups, which is more interesting. So to start pulling things out, consider the basic catalog data that you've got on an episode that you watch on a video application. Here we're talking about the title of the program, the series number, the episode number, and the synopsis. And that data is logically grouped together. And as it turns out, as we started asking questions, there's one team that manages that data, is responsible solely for that data, have their own database for managing that data. And so that forms a natural domain, and that if we can get access to it, is very powerful. We've got schedule data, and it turns out that there's a different team responsible for deciding when particular television programs should actually be shown on television, at what channel, what time, and this sort of thing. They have their own database, and they've got their own way of working and their own language for thinking about what scheduling means, and what episodes mean, and what programs mean. So a natural domain that we can think about writing a microservice around. We've got licensing as well, because even though stuff is scheduled to be shown on TV, it isn't necessarily available to watch on every device. So we need to know when something is available and for how long. And it turns out there's another team for that, although, interestingly, they happen to use the same database as the catalog team, but they are a separate team. So we like to think about those two things separately and model them independently. We've got images. Primarily only used on the websites and the applications that people use for catch-up. But again, there's a separate team that has an asset manager for managing these images, and we can talk to that independently. We've got guidance data, so whether there is bad language or objectionable content in a program, and that needs to be flagged. There's a separate team with a process for checking every program, and they've got their own database for doing that. And finally, a video domain, if you like. That's complex enough that, again, there's even a separate development team constantly working on making sure that the right assets are encoded for the right platforms. So we've got all these separate domains that we can use to start thinking about modeling our basic microservices. And it seems relatively straightforward and logical and understandable to do that. But it's worth remembering that not only in the case of, say, licensing and catalog were these currently using the same database. And lots of companies, you'll see one database being used for the entire of all of this. We also saw lots of examples of data that was copied between these systems. So, for example, although the schedule team had their own database for managing scheduled data, they copy the entirety of the catalog data into the scheduling database. And actually, some of the online websites currently in production are deriving catalog data from that database instead. So we have a spaghetti, and I think you'll see this at any large IT company where roles and responsibilities get confused over time, and you just need to step back and actually look very carefully at where data belongs and should come from. We talk a lot about what's the original source of truth for this data, and you'd be surprised how often people don't know. So we've got these separate domains. I like to think of them actually as a set of bounded contexts, which is a term from domain-driven design. And what that means is that we've got some common things between all of these domains. Let's say, for a start, the episode identifier, so a single unique number, UID, that is shared across the entire system. And there's also going to be some data that is universal, other data that's universal and every team is interested in. But there's also going to be things that are only of interest within those bounded contexts and shouldn't be shared outside of them. Take, for example, guidance. They're going to have an audit trail of who has actually approved this particular program, which is very important to them, but no one else in the company actually cares about. So we have already said that with these bounded contexts, we've identified teams that surround them, and a great thing we can do with our code is to align the boundaries of our code with the boundaries that those teams have. And that means that we are creating systems where there is a high cohesion within each of these bounded contexts, within each of these domain services. Because if I make a change to my license, the way licensing works, you would hope that it doesn't affect the way the scheduling works. Now, sometimes you're going to get coupling between those systems, but we're aiming for something that's really loose, because it's expensive. Every time you have to send a message between these different systems or communicate between these systems, it's expensive. So we're trying to model the most natural, but also lowest overhead boundaries between all of these systems. We're also thinking about the data that's shared beyond the boundaries of these systems in a resource-oriented fashion. Now, we're developing REST API, and that's to expose resources over REST, but it's even more important just to think in terms of domain modeling about the data and that we've named things correctly in a context that the entire business is happy with. So within a team, they may refer to something differently to the way people outside the team refer to it. And there's often a messy compromise where we try and find names for fields and properties that we're exposing that make sense across the business and also expose the right data. Getting a little feedback on this. We're going to concentrate on 3 domains today, because the others are broadly similar. And that will allow us just to use those as exemplars of what we were doing across the entire system. And I also think it would be helpful to show some basic REST APIs, just so that we've got sort of common understanding of what we're doing at this point. So here's a catalog REST API. Doesn't matter if you can't make it out too clearly. It's got a basic resource URI with the episode ID and some synopsis and other information that's needed by our video application. We've got a guidance REST API with a actually broadly similar URL structure and also keyed off of the episode ID. And that's been really helpful for us actually to key off one common ID across all of our microservices. We'll return to that again and again. And you may not have that in systems that you get to work on, but when you do, it can be really helpful. Here's the licensing API, which is subtly different. Here, although we're still querying on a single episode ID, we're returning more than one license. So that's, this is showing a list of things being returned instead. And it's also useful, I think, to talk a little about how we isolate and protect those legacy systems that we've talked about earlier, and how our domain microservices can do that for us with the REST API. So I want to briefly talk about that for a bit. What we've got here is a microservice in front of our legacy system that's more like an anti-corruption layer than anything else. You could also see it sometimes referred to as a facade layer, and people talk about the strangler pattern, which is, this is a sort of also taking us towards where we want to wrap the legacy system and protect other people, other systems that don't want to communicate with it from actually being exposed to any changes in that underlying legacy system. That's good practice at the best of times, but we know in this case that this legacy system is going to be replaced soon. We also know it's very old and very creaky, and the complexity of talking to it, be it over a strange SOAP service or some strange prepared statement, JDBC query, is best contained in a single place. So we've got a microservice that's going to do that for us. And because we're doing a REST API, and because we want to protect that legacy system from heavy access, we put a cache in front of it, an HTTP cache, simplest way of caching our data possible. We're using Varnish in our systems, but that's less important than the fact that it's got a really powerful cache invalidation API it's amazingly flexible. And what that means is that we can provide a really consistent view on the underlying system, and I'll show you how we do that. Because when a request comes in and something isn't in the cache, we go through to the legacy system, we fetch it, and we return it, and it ends up in the cache. So that when another request comes in, that gets served straight from the cache. But we have to deal with the situation where underlying data changes, and we want people to get the correct data straight away. We don't want a cache that's just serving stale data for 30 seconds. These are really important systems, and people need to see the correct data at all times. So we do that by, when we were integrating with all of our legacy systems, we insisted on 2 things. Yes, we need a way to query into the system and get the data out, but we also need a way of getting any updates, any changes that have occurred. And usually that could be just an audit table that we can query into, or they would send us an event over HTTP, even sometimes, or RabbitMQ. And that means that our microservice essentially has a way of finding out when there's a change in the underlying system, and it can use that to invalidate the associated entries in our HTTP cache. And that means that the next time a request comes in, or sorry, I should also say that having invalidated the cache entries, they can then confirm into the legacy system that that update has been processed, which is really important in case our microservice crashes. It means that we guarantee that we can always replay those events, and things may go wrong for a short amount of time, but we will, in a case of a disaster, recover to a consistent state. Our cache will reflect the contents of our internal legacy system. And having invalidated that cache, a new request comes in and we'll go straight through to the source system if it cares about getting the most up-to-date data. Some requests don't, so we can continue to search from cache for those as it happens. And this means that we've got a really consistent domain service building blocks, which we can work with for the rest of the talk. And despite the fact that we've been wrapping legacy systems, and we're now decoupled from any changes that happen to those legacy systems. There are separate teams, even as I speak to you, working on figuring out how to replace those systems. But if and when they do, it will only affect one of our microservices, which is crucial. Or in a couple of cases too, because of the nature of the legacy systems. Having got all those domain building blocks, we need to put them together and actually serve some customers with data that they want. So this is a picture from a fairly famous Netflix blog post about the API gateway pattern. And I think it's fairly easy for anyone to discover this themselves, but it's quite reassuring to see Netflix go ahead of you to do this, and for us very much so, because they're broadly similar to what we do. You can see at the top there's lots of applications, much as we do, that serve video, that need to communicate with back-end systems, and to get content from lots of different APIs. And the API gateway pattern says you can do this, especially when you've got many different ways of talking to your clients. So some of these may be using REST, but some could be using binary protocols and other things. So you put all of the complexity of dealing with these unique and strange integration processes in that one API gateway. And then internally, to the rest of your systems, you just use REST consistently. And the other thing that gateway can do is take one request for data from those client systems and fan out to all your services, build up a response, and send that efficiently back to the client. And that worked really well for Netflix. They've even open sourced some tools which allow other people to learn from what they've done, and that's great. Those tools weren't available when we were developing our API gateway. But I think even if they had been available, we would have still felt uncomfortable with this solution. Because what started to happen as we were developing our gateway in front of our client application, it started to accumulate complexity. You can see it on the screen here. It's a big ball thing that talks to everything else, and even that's a little bit of a red flag. And it just started to feel like, to us, like there was a little monolith growing inside our microservices architecture, attracting lots of business knowledge and understanding of how different systems fit together. And we were worried about that. As this one API gateway continued to grow in complexity, we started to think, what can we do about this? And that's really what the meat of this talk is going to be about, how we wrestled with this problem, which I think other people have too. But nevertheless, we've actually already got a huge amount out of microservices. And I want to talk about that, but first, a slide that I put in and I've forgotten about. It's also worth thinking at this point that these API gateways, they're a difficult problem. And what I actually started to see as I was looking at it over the last year was vendors coming along with solutions to this difficult problem. And this happens all the time in the industry. It's how vendors make their money. But it's also a little warning signal in my mind, because that's also how we got into a mess with the precursor architecture to microservices, if you will. And a lot of you will be familiar with service-oriented architecture systems, which I think even came in the 1990s. and describe a way of building up components that talk to each other independently in an isolated fashion. And very broadly sensible stuff. Things started to go wrong when vendors turned up and started offering enterprise service buses, which provided the difficult parts of a service-oriented architecture for you. And what I was a little scared of, I think I'm over scared, to be honest, but anyone would be after working on an enterprise service bus, was that the current generation of really sexy startups selling REST-friendly, microservice-friendly vendor tools might be the ESBs of tomorrow. Because, take this example, Apigee provide a security gateway that allows you to restrict access to your APIs. It's fine. If you want a product, it's actually pretty good. But they've also started offering other services on top. So you can now mash up your APIs together. You can start managing the complexity of how your APIs talk to each other in a configuration file in a cloud system. Scares me a little bit. Not to pick on one company in particular, CA Technologies, formerly Layer 7, have a similar product. So it's clearly a lot of movement in this space. And so that was actually another factor in us thinking about how do we solve this problem. How do we solve this problem before a vendor comes along and we're forced to use their solution instead? How do we solve it for us, just for us? Because what's going on is with this build it versus buy it mentality is what I've also seen referred to as simple versus easy. So a vendor solution makes things easy, but an ideal solution that's developed just for yourself makes things simple. And Rich Hickey did a very famous talk about this, which I've borrowed a slide from, where he explains, does a beautiful job explaining what this means. Because essentially, when you reach for something that makes your life easy, you accelerate the initial delivery on what you're doing. But basically by putting aside some aspect of your problem. Whereas if you concentrate on where things are hard and figure out why they're hard and try and break them into smaller pieces, you can actually end up by spreading your complexity around and creating a simpler overall solution, which will be more sustainable in the future. Maybe. That's what I'm hoping. But anyway, so far, we've already established some bounded contexts. We've established some domain services in our domain of television catch-up applications, and that's great. We've thought about those services and those bounded contexts in a resource-oriented fashion. That's also really helpful because that's already a language that we can use to talk to the business about what we're doing. We've put anti-corruption layers around our legacy systems, and that means those systems can change independently of what we're doing. But we've ignored those underlying data sources. We've basically left it to someone else to fix those legacy systems in due course. So we should acknowledge that that's not perfect. And we've also seen that this API gateway that we're continuing to grow is a concern for us and may end up being a monolith for our new stack. So we set out to solve this problem, and we did it the wrong way. But we learn a lot, so I don't see why you can't learn a lot as well from me making a fool of myself talking about it. This is what we had. We've got our domain microservices along the bottom, and I've drawn a little ball of spaghetti in our API gateway, which is how we started to think about what we've got. And so we were sitting there thinking, why is our API gateway so complex? So we're brainstorming this a little bit. And there are various ways you can solve this. One way that I feel I should talk about, even though we didn't do it, was to use batch queries. Because essentially, a lot of our problems came from making lots and lots of queries to different systems and then trying to put them together. If we could have just done queries that sort of put together a lot of what we were asking to into a single query, that would have reduced the complexity somewhat, or at least pushed it into the batch layer of our system. We weren't comfortable with doing that because we really liked the cleanliness of our domain APIs, accessing one resource individually. We were really happy with that, and the caching solution worked really well for that as well. It would have been more challenging, not impossible, to provide a good caching system for batch queries. And so we wanted to look for a way to solve this problem without resorting to batching. So what else was going on? Well, one way to think about all these queries that we're doing against all these source systems is it's a lot like what we used to do when we were building a monolith with our single database. Instead of doing these complex pieces of logic that span lots of database tables and do a database join on all those tables to produce something that you can then surface to the user, we're doing that join over HTTP instead. Not SQL, HTTP. But otherwise, there's a lot going on there that's the same. And with that in mind, we thought, well, why not use the data store to manage this complexity for us? How would that look? How would that work? And so we tried it out. This is the Video On Demand Aggregation service. And if that sounds like a smelly name, it will turn out to be one later on. And this service allowed us to decouple some of the complexity from our system, to put it in one place. We could, for a start, we could get the API gateway out of the aggregation layer. We now had separate API gateway, in theory, for each client application. And it only had to worry about the translation to whatever protocol the client used. And internally, it had a single API that created that managed doing all the extra requests and putting together a single response. This new VOD service gets its own data store. So instead of every time you do a query, that gets broken down into lots of HTTP queries. You have a single query against that data store, which means less HTTP queries, which is good. And it means we can exploit whatever data store that we use, and that can end up being, and was in our case, much simpler, because instead of doing, in some cases, 1,000 HTTP calls, you do a single query. Document stores are great for managing this sort of accumulation of data, Mongo or something like that. We used Elasticsearch, and we could do a simple query in Elasticsearch, which pulled together all the information we need. It's very powerful. Now, the other difference with this to the previous slide is that the arrows that previously went all the way from the top to the bottom, at the bottom now the arrows go the other direction, because instead of the aggregation service making calls out to the individual services every time you request some data, we expect the underlying domain services to send events to populate the video on demand aggregation service with data, so that we can query to that service instead. So it's worth talking a little about how we did that, how we populated the data store on the aggregation layer, and did so in a way that was reliable and consistent. So here broadly is the architecture that we saw previously, just extended a little bit, because we were able to leverage what we were already doing to invalidate our caches to send update events whenever there were changes in our legacy system. So you've got an update event that comes from a legacy system. We use that to invalidate the cache, and we just add an additional step, which is send an event to a queue, and once that's on the queue, confirm it as read in the legacy system. We've extended the transactional boundary of our handling of updates, and we can, if anything goes wrong, we're confident that we can replay that event and get that update out and into the queue. At the other end, we need to take the events off the queue and put them into the data store, our big denormalized aggregator service data store. So we've got our service pulling events off of the queue. And at this point, I should stop and say that you might think that those events are all the data that should go into the data store, or maybe a delta for the change that should go into the data store. But actually, when you start working with queues, you discover some really interesting things that you don't realize. Particularly with SQS and AMQP, they provide what's called at least once delivery guarantee. And that sounds crazy when you first hear about it, because you're like, what? I put a message on a queue. I should get it out the other end. What are you saying about at least once? And this is the understandable idea, really, when you unpack it, that we can make sure that you get the message, but we might accidentally send it to you twice in a small number of situations. We also might send it to you in the wrong order, and you just need to be prepared for that. And that actually makes sense. If you go think back to the previous slide, our microservice here could crash, for example, and we'd be replaying our events. And unless we had a way to make sure that we didn't send the event again, if we'd already sent it to the queue, we'd end up sending it twice. So it can be easier to work this way. But it also means that we need to make sure that the events can arrive out of order and duplicates can arrive, and that that's okay. And the easiest way to do that is to not actually send the data at all, just to send something that's idempotent. So it's called the idempotent receiver pattern. And essentially means that we get just the episode ID, and then we use that episode ID to get the rest of the data that we need. So we make a call from the aggregation service back to the domain service and say, okay, give me the data now. And that way, if we get duplicates or things come in the wrong order, that's okay, because it's only at the point where we go back to the source to get the data that we start caring about the order that we get events in. And so from that point forward, we're very much concerned with the order of our events, and we make sure to keep things sequential. So we insert into our actual eventual data store very carefully from that point forwards. But we still need to confirm back to the queue that we've processed that event. And if something did go wrong, that would be okay again, because we just pull the event episode ID off the queue, get the data from source again, and it could have changed, and that would be fine, or not, and it would still be okay. Insert into the data store. And what we've ended up with is a reliable way of making sure, again, that as well as the data in the cache is correct, that the data in our aggregation service is correct. We've also started to have two very different styles of microservice, and it's worth pausing to compare and contrast. We've got our domain service and our aggregation service, and in the domain service, it's a bit like a single database table in an old style monolith. In fact, a lot of people recommend, if you've got a microservice, try and make it one database table. Why would you need more? Whereas our aggregation service is more like what we used to call a projected view on a number of database tables. And this is what happens when you have a trigger that runs on some database tables. It says, anytime there's any change, I want you to pull that change out of that table and put it into a denormalized table that contains the data from a number of different tables. And it usually tracks a little bit behind what's going on in the actual real database table. That's okay. And it is eventually consistent instead of actually consistent with the real data. Also, the underlying domain service has got teams of people managing the data. There's people logging in and making changes to those domains, and that means that they need to be able to have the ways to do that. We don't provide them in these legacy systems, but if you contrast that with our aggregation service, they should only be populated by events. No people should be logging in and fixing things if something goes wrong. We should, in fact, consider the systems as one, a long-lived data store that has to be backed up and maintained so that if there's a disaster, you've got a recovery plan. And the other one is completely ephemeral. If AWS tells you that system's going to go down, fine, okay, we'll rebuild it from scratch. And it's extremely important to think about this aggregation service in those terms. It also means we're starting to move towards something that some of you may be familiar with, and we really like, called event sourcing, where the data is derived from the events rather than the data itself. So you can replay your events and recreate your system at any time. So we've got those two different types of service, but actually there's some real problems that start to emerge with adopting this approach, and those appear as soon as you start using this service. We've got our basic domain service REST APIs here, and what we're doing, remember, in our aggregation service is taking those resources and putting them together into our bot aggregation service. And we have a nice query. Here we've got an example where I'm the iPhone gateway. I'm querying for things on the channel ITV for down to Maddie. And that's nice, it makes sense. And actually, what we're returning is also nice, but a little bit dangerous, because it's a denormalized view over all the data in all the domain services, just put together in one lump. That's okay to work with, actually, if you're a client developer. The problem happens when, inevitably, we want to change anything. If we make a single change to any of these underlying domain services, we need to update the broad aggregation service at the same time, because otherwise people won't be able to use this data. People have started using this broad aggregation service instead of using the underlying domain service, and it's got a massive coupling problem. What we talked about earlier as being desirable property for our domain services to have, loose coupling. When you make a change in one service, you shouldn't have to update another service. We've got really seriously in our aggregation service, because if you make a change in any one of those underlying domain services, you definitely have to update the aggregation service. And this is a really bad idea in the microservices architecture. You don't want to have any microservices that are that coupled to other microservices. And you see this in any situation, and that should send up a red flag, and you should stop and think about how to undo that. Nevertheless, we've still got something good out of this. We remember that we pulled out our API gateways, and that's good. We've eliminated a large number of these inner join style HTTP calls, and we've actually got code that's much easier to maintain because the complexity has been pushed into a data store. We've got an Elasticsearch query that is very easy to change and extend, whereas previously we have to fiddle around with lots of different HTTP calls and how they fit together. On the other hand, we've acknowledged that we've got this really serious coupling problem between our aggregator and our domain service, which means that the aggregator has to be updated if any of the domain services change. And we can't live with that. And so we set out to find the right way, how to actually solve this problem properly and avoid this issue. And to do that, we couldn't just iterate on what we were doing. We felt that we'd reached a dead end. We needed to take a step back and think about the problem from the fundamentals again. So we went back to our original screenshot that we saw earlier, and where we identified the domains in our system. We looked at that again, and we thought, is there something here that we're missing? Is there something that we don't understand? Is there something extra that we need to do that we haven't spotted? And then thinking about it, and wrestling with it, and looking at it more, we came to realize that yes, actually, something really fundamental is staring us right in the face. And that's just the idea of whether or not you should be able to get to this page or not at all. Because just frankly, none of this stuff matters if you can't actually see the episode. And so what started to emerge was this idea of availability that encapsulates a lot of what's already here, but definitely adds some additional business domain-specific logic on top of it. This episode should only be playable if the catalog data is correctly populated. It was scheduled and actually shown. It's licensed, of course. Has images. There are videos available for your platform, and the guidance team have signed off on it. And only if all of those criteria are met is it available. That's a separate thing. And actually, look down at the bottom. We've got something that is just about availability. We say 5 more episodes. And that's a Boolean property on each episode. We don't care if these 5 more episodes have synopsis or what image they have. We just want to know if they're available. And so we need a service just for that, perhaps. And that's what we set out to build. What we did was we took those existing domain services that we'd already got, and we modified our video on demand aggregation service. And we kept that query API because we liked that, and that worked really well. But in the response that you get from the availability service, instead of all of the denormalized data returned to you, all we give you back is the episode ID, because that's never going to change. That's a unique identifier that's going to be consistent across all our systems. and a Boolean property saying yes or no, it's available or not. For everything else, you can go to the original system and find that information for yourself. And we actually provide links to make that easier. And in some cases, we don't provide links. If it's the guidance team have signed off on it, but there isn't actually any guidance text to display, you don't need to include the guidance link. And similar things occur for some of the other domains. But we can also link specifically to the actual schedule entry that's responsible for this episode, rather than every time this program is ever shown. So there's all sorts of things we can do with this API without returning all the data, because we still need all that data. We need to continue to populate this internal data store with all the information about the episode so that we can query into it and find if something's available. But we're trying to avoid exposing that data and having that coupling between the domain service and the aggregation service. But providing these links, we're also starting to do something else. We're actually getting to a more mature REST API. And I mean, it's kind of obvious in hindsight, but we crept up on us. Because what we've been developing up to this point were what's often called level 1 or possibly level 2 APIs in what's called the Richardson maturity model, which is basically saying you've modeled your data quite well, you've got the right HTTP verbs, but you haven't really thought about how those APIs fit together. And by including these links here in our availability API, by linking back to the original data, we're actually building a much richer REST API overall. It's often called HATEOAS, hypertext as the engine of application state. And what that means is that instead of the clients understanding where all the API points are and what they should call in what situations, it's the API response which tells you what state you're in, what API calls you need to make at that time. Before I move on, because we're using JSON instead of XML or some other mechanism, we need to figure out how to show links, and we chose how. I don't know if anyone else is using JSON API, but we love, it's called it's the hypertext application language, and it's really, really simple extension by convention to JSON for embedding links. And there's also, even now, browsers on the internet which just can pick up and find those links, so it's extremely powerful, and we like that a lot. But to consider what's going on, before we draw a veil over this, I haven't updated this slide, unfortunately. You've got on the left, it says client, but think of it as the API gateway. For example, the API gateway for the iPhone application. It does a request for all of the Mr. Selfridge licensed episodes that are available. And the availability service consults its internal data store to find out which episodes are available. And then it returns just the identifiers. It doesn't, even though it knows all the other information, it probably knows the synopsis, it knows when it was shown, it doesn't return that data. It just gives you the episode ID and the links to where the gateway can get the extra information. And that also gives the gateway the flexibility to choose what extra information it needed. So it needs the licensing information so it can show how many days are left, but it may not need any catalog information. Perhaps there isn't room, or it's a small form factor device. So it gets to choose what calls it makes. Instead of previously having to make every call just to figure out if the data was correct before whether you can actually watch that episode. Now it knows that this episode is well formed. It's just a matter of making the API calls that are appropriate for the data it wants to show. And that's been working really well for us. So just to talk about, in conclusion, on that subject, how exactly that was good. We've identified a new domain, which is always a wonderful place to be. It's highly cohesive. We can talk about that, and we know when we are that it is a thing. And even the business is comfortable talking to us about the availability. In fact, they were like, oh yeah, of course, why didn't you ask us in the beginning? Of course this is a thing, of course we need that. And now that you've built it, we also want to be able to generate reports based on these availability APIs, so that if something is scheduled and licensed, but the guidance team haven't entered the information yet, we'd like a notification so that we can chase them up and get it done. I'm like, yes, that's going to be quite easy, because we've got an API and it does exactly that. So it's because it fits well with the business and what they actually want. It opens other doors and is extremely extensible. We've decoupled our domain services from our domain aggregator because we're not returning that data anymore, because we're linking to it. That means we can make a change to the data in those underlying domain services. We may still need to update the aggregator in some situations. Actually, we don't in lots, but we may. But we don't need to update the API of the domain aggregator every time we make a change to an API in the underlying domain services. And that's so powerful because it's APIs changing, which really generates friction and it gets hard to manage. It's these integration points that you want to keep as stable as you can. And you do not want these changes to bubble out to every microservice in your system. We've still compromised. We've pushed some of those HTTP joins and less of them back into our API gateways. They're still doing more HTTP calls than they were previously. They're doing just one, and now they're doing, in the most extreme situation, maybe 100 API calls. But previously we were doing well over 1,000. So this has massively reduced the complexity. And there may be opportunities now that we've identified this domain to pull out other things and simplify things further. Who knows? We've also got a challenge around testing, and I'm not going to go into this too much, but we're not quite sure how to test this aggregation service in isolation. There's becoming very popular at the moment, you may have heard of it, and we'd like to use it more. It's something called consumer contract testing, which basically says you can interact with any one microservice by making API calls to put it in the state that you want it to be in, and then you should be able to replay those API calls later on and have the same results. And it's actually quite difficult to replay the events, and then quite complex to make sure you send the right events to populate our system in the right way. And so it's not great in that respect. But we're still extremely happy with where we got to. I also said that earlier on that I wanted to talk a little bit about versioning, so we've got maybe 5 minutes. I'll do that now. Because we had all these different microservices working together, we were thinking a lot about versions of APIs that different microservices would be consuming. And actually falling out of this work that we did on HATEOAS was a much better understanding of how versioning should work. Because we started out, I think as most people do, doing the simplest thing possible and making it work. And we put a version in our APIs that was just a number in the URL. And there are strong academic reasons for not doing this that everybody knows and then ignores. If you've got a resource in a REST API, it should have a location that is permanent and should never change. That's the idea about the whole interwebs. You can always go to that place, and 20 years later, that GeoCity page is still there. If you're versioning your resource, that means that as soon as you create a new version of that same resource, it's at a new location, and you shouldn't really be doing that. Nevertheless, we do. But we came into a really interesting situation where actually it wasn't working because we did it this way, and there's a practical reason not to do it, which was a lot more exciting than an academic reason, so I'm going to show that. Because of this availability API, we are also including a link to the catalog API. That version shows up in two places. Also, the availability API version as well. And what that means is that if I was to update the version of my catalog API, I would also need to update the link in my availability API if I wanted people to use the new version of my catalog API. If I didn't update the link, they'd never find out about it, so they wouldn't use it. But there's a problem if I do update the link, because I've now increased the version that we are exposing from the catalog API, which has changed the way that the availability API works, because people will follow the links and expect things to work in a consistent way, and now they're not. So if we update the version, actually, on the catalog API, we also need to update the version on the availability API. And that means we've reintroduced all the coupling that we worked so hard to eliminate by not returning the data, because we're still returning the version number, and that's just as bad if there's a change. So can't do it. Had to think of a different way, we had no choice. And it's actually a really interesting place to be. There's one solution that everyone will tell you, which is don't version your APIs at all. I'm not that brave, I'm not that smart, I should say. I know I'll screw things up and need to make a new version of my APIs, it's going to happen. So yeah, we ruled that out. You can stick a version in your host header if you want. That way, if you've got a relative link, you're not concerned with what the version of the API is. That could work. I've never really seen anyone do this out in the wild. But this kind of gets to a place where you're versioning your entire API ecosystem in one place. So if you've gone to all the effort of breaking your monolithic system down into individual microservices, only to version your entire system as one monolithic API, doesn't seem like you've moved too far forward. So let's rule that out as well. We can do a number of things instead. We can require a custom version header to be included whenever anyone makes a request. So that takes out the version number from the URL and sends it independently, out of bound, if you think this is a technical way of saying this. So the API response that you get from the availability API no longer tells you what version of the catalog API you should use. That's something you discover for yourself and you manage yourself. There's a couple of other ways you can do that too. You can set a version number in a request parameter because it's an additional parameter that isn't specified in the link. You could require a version in the accept header media type. There's two different ways of doing that. One is the actual media type, one is a version on media type. That way you leverage content negotiation to say what version of the API that you're going to get. It's crucially for all of these, the link doesn't include the version. It's you that specifies and manages the version yourself. And any one of those actually works very well to achieve that. I like the content negotiation one, sticking it in either of those media type headers, because that leverages HTTP's what it's already doing for you. It's already got a mechanism for helping you decide what version of a resource you want, and it's a really powerful way of requesting a version and then actually getting it or not getting it. And the HTTP provides semantics for that. Unfortunately, lots of frameworks don't understand HTTP, and lots of routers and firewalls don't understand HTTP, so it's not always possible. But we like that way of doing it. However, whichever way you do it, there is a problem. There is a reason that people like to put the version in the URL. And that's because it makes it easy to figure out what you should do if someone isn't really thinking about versions at all. Because if all you've got is a URL with a version in it, you'll use it, and that works, and that's fine. If you don't know what version of an API you want, and you just send an HTTP request without the requisite headers, what should the server do? How should it respond? You've got a number of choices. You can not work at all, so you can break and just tell them, no, sorry, you must send that header, which is a really nasty developer experience. So we've all been working hard to make these beautiful REST APIs that are easy to use and everybody loves, and then we require a special header to be set, and we break if it's not, and everyone hates us. So we don't really want to do that. The other alternative that's easy is you always return the latest version of the API. Which is actually even worse, because people won't even realize that your API is versioned, and as soon as you make a breaking change and introduce a new version, they get that breaking change, and they may not be able to introduce that header and get the old version back, and suddenly you're in this space where you're having an argument, making breaking changes. So we actually found another way forward, and really I just wanted to sort of finish up the talk by showing you that very quickly. And that was just by embracing this content negotiation, and by looking at the headers that we've got and doing the right thing. Here's a HTTP request that we might get from a web browser, someone sort of learning about our API and figuring out how it works. And that request contains the URL for the API. It also contains an accept header that's normal in every browser, which is I want HTML because I'm a web browser. But I'll take whatever you've got. Oh no. I thought I was losing the feedback. And that means that you're saying you want the HTML, but you're happy with whatever you've got. You're happy if you get the versioned response. And so you'd be perfectly happy if you got the latest version or an older version, but you just want something. And we say at that point, okay, we could give you the JSON response because your accept header says that you'd be satisfied with it. But since you actually want HTML, we'll give you HTML. So here's our response. Content type HTML, and here's how it actually looks. It's the HTML version of our JSON APIs. And because it's HTML instead of JSON, it's not machine readable, which means no one can accidentally make the mistake of using this API without setting a version, because they'd be consuming HTML instead of JSON, and there'd be a message at the top telling them how to send the right data. But if they happen to use a browser, it's very pretty, and they can get to use it, and get to learn it, and they can find out what they want and how they want to make it work. And that's really nice for our client developers to work with. They really like it. We've done all the prettifying for it as well. And even better, you can only see one at the bottom, but all of our links actually work. So you can click through and explore the API in a web browser and just discover things. There are other ways of doing this. A lot of you, I'm sure, will be familiar with something called Swagger, which allows you to document your API and then provides a nice browser in another space that you can use. But this is really interesting because instead of providing an API format for one particular endpoint, where if you get the response, you then have to figure out how to take the response and plug it into a new request. We can actually generate links which include within them requests, parameters, and path parameters that you've previously set at other points, which is using that whole HATEOAS principle. So for example, if you're in England, you get different content to if you're in Scotland. And so once you set that request parameter, we make sure that all the links maintain that parameter all the way through. And that's been really nice. It's still maturing and we're still playing around with it, but I've not seen anyone else doing anything similar. It's worked really well for us, so I wanted to share it. Thank you, everyone. I hope you could hear me. I'm sorry if without the microphone I wasn't so loud at the back. And before I finish, I just wanted to say that this is stuff that worked for us. These aren't best practices. Please do not go away and say, I saw this talk and they said do this, so we must do that. These are things that work for us in one situation that we found ourselves in. We were in one context and with one particular application. And I'd hope that if you were in the same situation, you'd agree with us that this was one way of solving the problem and that worked well. So there's stuff that can be learned, but it's not exactly how to do things. I think it's more around sort of the way we learned things as we went through this and the principles that came up. And so I wanted to just quickly race through those and summarize essentially what we've learned. We've, importantly I think, we've got an agile project here that we let the system design emerge during development. Instead of trying to define our microservices up front, we allowed them to be discovered as we went. We were flexible and we threw things away and we made changes, and it was really powerful and often very easy to forget and to just define things at the beginning. Even as we iterate towards the goal, we're iterating on a fixed architecture, and here we really weren't doing that. We also found that as we were developing these microservices, and maybe you caught a hint of it through the talk, that we were promoting a lot of concepts that we're all familiar with from traditional patterns books around application architecture to integration architecture. So we're thinking about things that we used to think about in terms of how components work together, and thinking about how microservices work together, but using a lot of the same concepts. And I think we're going to be talking a lot more about that in the microservices community over the next few years, because there's so much stuff that we already know that we can draw on, and we should be conscious of that. You may need to think more about how you compose your domains. We certainly had to think about it a lot, and I think as a community we could talk about it more. This is one way to do it. I think there are others, and it'd be great to get into dialogue about ideas and other ways of approaching these problems. So even if it just sparks some some thoughts and some challenges to our approach. I think it's really interesting just to put this out there and talk about it, because not enough people are, in my opinion. We mixed our architectural styles a lot on this project, and I hope you could see that. And I think we talk a lot in the microservices community about the power of using different languages. So you can do it in Go, and you can do it in Scala, or you can do it in Ruby. We don't talk enough about mixing different styles. Should I use REST? Should I use events? Should I use a consistent data store? Should I use an eventually consistent data store, denormalized, SQL? And you get so much flexibility by putting all of those things together and using the right one in the right situation. And that's really the power of microservices. Microservices aren't cheap, so you should get something out of it. And this is one of the big things that you get out of it, in my opinion. And finally, just watch out for that monolith. It keeps coming back, honestly. Crept up on us, as you saw in the talk several times. We thought we were throwing away one monolith. Imagine how bad we would feel if we got to the end and we realized we built another one. And actually, we should all be a bit humble here, because think about the people who built those existing monoliths that we're often replacing. They set out with the best of intentions. They didn't set out to build a monolith. They ended up with a monolith. It just accumulated things, and that's easy to happen anytime. Even if you think you're building microservices, one or two of them can start to grow. So yeah, thanks. Do we have time for questions?
Of course.
I can't see anyone except the front row. Does anyone have a question?
Over there.
Yeah, to the right. Oh, hi.
I have a question. Unit ID, where I missed the point. So how you create this and distribute this over different services? If you create a new thing that you show them.
Okay, I think I understand what you're saying. So the question is, if I've got this episode ID that I'm saying is actually shared across every other microservice, how do we manage that? Because really there should be only one place which knows what the episode ID could be. Think about it. That kind of makes sense. I guess the availability API is part of dealing with the actual messy truth of the inconsistency that you could get where in some situations the episode ID isn't created correctly. Because you allow every system to have whatever episode ID they want. There's no checks and balances. But at some point you need to, when things come back together, you need to check that everything is there. In our case, one of the systems is responsible for making sure that the episode ID is unique. And then that should be whatever the first system is that creates something in that space. And then I suppose it's not currently modeled this way at ITV, but ideally there's a life cycle that, in this example, program content would go through. It starts off as just an idea that someone has, and they scribble something down like write a quiz show where the contestants hang from a building and have to answer questions or they fall to their death. And that idea then gets evaluated and discarded or not based on whether it's appropriate. And then someone shoots a pilot, and that's a different thing. And then eventually, after a series is made, it's shown on television and is made available for catch-up. And all through those, all through that life cycle, systems should be passing around the events to make those changes. And you just have to monitor that essentially as well. Your monitoring system should really be keeping an eye on these unique IDs, and then you can see when there are inconsistencies and you can fix them. But it's as long as only one thing's creating them, it should work. And yeah, and we've used it as well to solve some problems when because in actual fact we didn't always have consistent episode IDs, and we could fix that.
Yes, they're in the back.
How are you managing the microservices?
So you're asking the question I deliberately started out by saying I wouldn't answer.
No, this is the question.
How specifically, what do you mean by manage?
So, for example, there's a trend to say, right, each microservice will live in like a Docker container, which will be managed by Kubernetes, or choose your flavor. So I was just wondering what you were doing.
So, one of the disadvantages of starting out 2 years ago was we didn't know Docker would be so big. We're currently using Docker more in development, but actually we build RPMs and we use Puppet to make sure that those are installed in the systems that are configured correctly. We're not very happy with that solution, but at least we're in AWS. Until about halfway through the project, we were using our own data center, and that was a nightmare. So that's where we are. It's not ideal. Hi.
How is it pronounced? Hypermedia as the application?
I don't know how to pronounce it. I say maybe HATEOAS or HATEOAS. I think.
HATEOAS. Okay. I really didn't know how to pronounce it.
Neither.
So we worked in a microservice environment for 2 years. We ran into similar problems like you did. We made things wrong, and I think 1 year ago, or 1.5, I also discovered this potential of HATEOAS, and I tried to introduce it or convince other people that this might be the solution, like you said, for this aggregation stuff. And I really discovered me having a hard time to convince others that this may be the way to go. A lot of argued, you have a lot of HTTP requests then, and I said, okay, you have a connection, you can do it over the same connection, you don't have problems with the client, that you always knew a long time ago that you have this problem. But I couldn't make it to the end because the others, the big guys, Google, Facebook, Twitter, all of them are not doing this, are not using these links. They all use some kinds of fields and selecting what entities they want to have on their major services in the backend. And they have one aggregated response where there are no links anymore.
Things like the Graph API, yes.
Yeah, and I couldn't argue against this. And how did you also have this problem? So there were several guys saying, hey, let us do the things like Google and Facebook does, or did you agree all on this?
So I think we might have a harder time right now because there's a lot of tools actually out there right now that help you to build these sorts of graph APIs more efficiently. Things like Zool from Netflix, which provide this DSL that you can essentially say, here's the plan that you should run, here's the graph query that you should do, and then the gateway just becomes an execution engine for that DSL. And that's a lot easier to do than it was. I think we were just lucky. One thing that we concentrated on that maybe made a difference was because we thought so much about caching from the beginning, from day one. And I should say, actually, to the extent this was unique for me, but maybe it's more normal now, where half of our system tests were just for checking that the caching worked correctly. And I've never had tests for caches before. Caches are something that usually the ops team introduced 3 o'clock in the morning on the day you turn things on because it doesn't work fast enough. Whereas we were saying from the beginning, no. How do we use HTTP? How do we use the age headers? How do we use, we weren't using e-tags, but we were talking about it and thinking about it. How do we do this properly? And as a result, we've got a few milliseconds response times for a lot of these APIs. The other thing that we were doing was using asynchronous code, so called reactive code. I think a lot of people talk about at the moment. We're using Scala, but you can do it in Java and other languages as well. So it's a lot easier to create promises and futures where you make a number of requests and then you can put the responses back together, but only at the point where they actually all complete, and that's a lot easier to manage. So that might also be a factor. I'm not even sure we did it the right way. it's a bit scary to do something that, and then you're up against Google and Facebook, and they've done it a different way. And we often actually see, take something example like versioning. There's all sorts of examples out there like Facebook and Google where they've done terrible version APIs, and they started to fix that, a lot of that in the last year or two. But as examples on the internet, actually a lot of these big APIs can be quite poor.
But you being confronted with that argument that, hey, why does Google it does not this way with links with HATEOAS and things like that? Not Facebook do it in this way. And the problem is you can't, as a small developer in the team, you can't argue against this big players or their APIs.
I think a good position to be on anything that you do. Every time that we were working on the architecture for our system, we were always like talking about how to go back to the first principles, go back to why theoretically this is a good idea. Don't just tell me GitHub does it, so we should do it too. Tell me why GitHub does it and why it's good, and then you actually think about why it's good rather than just cargo culting your way through the code. There was a question over there, right? Is it still asked?
Yeah, I'm still not sure if it's a good question. No. I was wondering, your system seems to be very happy just being some sort of copy of the truth, with all the legacy systems still in place, happily working at, or still continuing to be as they are. And I see a lot of the times I'm facing the challenge chopping down the original monolith or the legacy systems. Have you done any thought about that, or was just given for you keeping said systems in place?
There are conversations I'm engaged with at the moment with some of those teams, but actually I'm trying to not get too involved because some of the teams that you're working with some of these times are people in their 50s and 60s who've been working on these applications their entire life, and they've got all these ideas for ways that they want to improve the systems, and actually often what's needed is to just start taking small parts of what they do out into a separate team and doing it, and then gradually reducing what that legacy system is used for. We did do that, we are doing that, but just restricted to the online department. So, for example, teams that I weren't involved in, but were also going on at the same time, we had this monolith that we had that would take all the data from the underlying schedule licensing systems previously, all in one system. Also was a CMS system that managed content for our entire website. Also was the image, still is actually the image management system, and is also the video asset management system. That's all in one giant .NET stack, and it's still there and it still does all those things. But we've taken the CMS out. There's another team that now manages content management. And we've taken out now with this project the management of metadata. And there'll be a project starting later this year to take out the video assets as well. So we are doing it for one part of what we're doing. And the way, you have to think about it in a much larger scale than I've had a chance to with this talk today. Because the life cycle, you can't really turn something off, and really you've got to measure the success of any of these projects where you're replacing a legacy system based on when you turn the legacy system off rather than when you turn on the new system. For a very long time, and we're still early days actually. We've launched our application on smart televisions, and we're currently working on replacing the website, and we'll be doing Android and iOS phones later this year. So it's a really extenuated process. It'll be about 10 years before we replace some of those underlying systems. Someone right at the back.
Yeah, often coupled with the switch to microservices. So often coupled with this. You look now there, or are we?
I can't see.
Okay. So often coupled with the switch to microservices is a switch for the culture to also go more towards DevOps, and that the developers take more ownership over the deployment and the actual then running of it. Did you also switch culture to that as well? Are you on call right now?
Good question. No, I'm not. I did say I wanted to be on call, and yeah, they wouldn't actually give it to me, which is odd. But the reason was because other developers might feel guilty, and also, but we are changing the culture slowly. It's another one of those questions. I explicitly said at the beginning I don't have time to talk about that today because it's such a big and interesting subject. Essentially, I don't think you should start a microservices project unless, as you said, you're comfortable doing DevOps and you're comfortable ideally doing continuous delivery, and you've got an agile company with product-oriented teams that are cross-functional. Okay. Some other buzzwords I missed, but we started anyway, and we used it as a wedge to make the change we wanted to be. So we didn't have permission to do DevOps, so we went and sat with the operations team until they told us to go away and take some of their operations people with them. And we didn't have permission to do continuous delivery because there's a sign-off process that's several weeks long. So we automated the sign-off process and started sending them the sign-off requests to do a release far more often than they were comfortable with, so that we reached the point where they said, okay, you guys are special, you can do a release in a more automated and less bureaucratic fashion. So just gradually just pushing at the boundaries. Yeah, but you need a really strong team still, and if you're not doing these things, you at least need to be comfortable with the idea that at the same time you'll be doing microservices, you also need to be figuring out how to do DevOps and continuous delivery and a whole bunch of other difficult things. Does that answer your question?
Yes, it does. Thank you.
Hi.
Well, could you talk a little bit more about the team structure? What kind of model are you following? Maybe Spotify or something like that? If you have something special, how you set up the teams to reflect the microservices?
Sorry, you said Spotify?
Yeah, as an example. Like
right, okay, because they do the...
You're not doing scrums or something like that? Or?
And the other thing they do, of course, is they have guilds as well as product teams, so it's a sort of matrix process with them where they have cross-functional teams. As do we. We've got developers, testers, operations people, and small numbers of product people embedded in our team, and we're spreading that to other teams. It's an organic process. You kind of need to bring people into it slowly. The biggest challenge for us hasn't actually been getting a cross-functional team. It's been defining a coherent product that doesn't have, because you've got your core team and then you've got influencers surrounding your team who will turn up to Scrum meet. We're doing Kanban. Who will turn up to stand-ups at points and drop a bombshell and say, hey, actually we've got these microservices, we want them to do this. Drop everything you're doing and change your approach to this way instead. And they're not coming to us through a product owner because it's not clear what the product always is. So that's the real challenge for us, is around clear products and clear boundaries. Just as we've tried to get to a point where we've got clear separation between services, we also need to get clear separation between groups of services, and that's actually really challenging. What point do you switch from a horizontally integrated team? We had a team with JavaScript developers, server-side developers, and all the way back to the operations people, to a team which is horizontally based, where you've got a client team iterating on designs and a server team improving the performance, perhaps, or the capabilities of the back-end systems. And we are in the process of trying to figure out when we do that flip and for how long.
How many people are we talking about?
Sorry?
How many people are we talking about?
We started out with we did an initial proof of concept project, actually, for 3 months, just to prove whether we could actually talk to these source systems, because no one believed that we could. Previously, we had this actually completely impossible to understand sort of integration process where data would be FTP'd around and in giant XML dumps, CSV dumps, over periods of hours, to the point where you could make a change in some of these underlying systems, come back a couple of days later, and it might have been updated on the website. To a point where we could demo after 3 months from a team with 4 people, including our ops specialist. making a change in one of these underlying systems, which looks like a big Visual Basic application that lots of people in the room have never seen before. And we made a change there, and it appeared instantly on our proof of concept website. And that's what got us the funding to build the team. And then we grew from there to, I think 12, 14 people, which actually I think is a bit big, but that's where we've just split actually, and we're struggling with how to manage that. We've got one team continuing to iterate on the smart television application, and then I'm working with the existing website team to help them use the APIs and make changes to the APIs that they need. So we're currently in a state of flux, I would say. We should probably continue for another year while we really solidify these boundaries. Oh my, okay. Yes. Hi.
When you were preparing the business case,
yes.
Presumably you had some sort of financials. Was the business case premised on the outcome reducing costs, or was it premised on perhaps increasing revenue by giving a better customer experience? And at the end, or as you're reaching the end of your project, how close are you to realizing those targets? Or is this not that type of project?
Oh yeah, very interesting. Why do we do things, and do we learn from the experience? Usually we don't know, and no, I'd say that that should be universal, I think, for far too many companies. We did have a business case. Actually, it was interesting. We turned up and said, "Can you give us £100,000 to try this out?" And they said, "We don't deal in numbers less than $1 million." Which was annoying, but I think we figured that one out eventually, probably by stealing the money from a different project. There was a program of work that's been ongoing for a while, and I'm not actually sure. You'd need someone senior than me to explain it. How the business case was sold at a board level, but essentially the business doesn't have the agility that it wants to respond to changes that it wants to be able to make. They currently still, so this is ongoing really, they can come up with an idea and it can take 2 years to execute that idea, and they want to reach a point where they can respond much faster than that. And so we just have to simplify every bottleneck as it's identified until we can do that. And this is emerging as, after a lot of experimentation and trying it out, talking to a lot of people, as the best way to do that by isolating these parts of the business so that they can evolve independently and making the boundaries clearer. Just makes the whole thing simpler and will hopefully reduce costs in the end. Right now I would say costs are probably greater because of course we're managing a legacy estate and a new estate. But we are also improving the customer experience a lot. One of the things that we did by going to source for a lot of this data was discover bugs that people were aware of but would never been able to fix, so they just didn't understand what was going on. And because we could actually talk to the underlying teams, talk to the team, manage the underlying data, we could figure out what the right thing to do was and even make changes, small changes to the underlying data systems. So we're actually getting a better customer experience out of this as well as reducing costs. But I couldn't give you numbers, so I don't know. You'll let me finish my beer, thank you.
Yeah.